Good morning, good evening, good afternoon, everyone. Wherever you are hailing from, welcome to OpenShift TV. I am Chris Short, Principal Technical Marketing Manager on the OpenShift team at Red Hat. I am joined today by two of my fellow colleagues at Red Hat, Mario Vázquez and Ryan Cook. Mario, please introduce yourself to the audience.
Hello, everyone. My name is Mario. I have been at Red Hat for a little bit more than 3 years. I'm working on the solutions engineering team, and currently I'm focusing on multi-cluster and GitOps, all the things, basically.
Nice.
And with me today, we have Ryan.
So I am Ryan Cook. I'm with the Office of CTO. We're working on emerging technologies for Kubernetes, storage, multi-cluster storage, things like that. So it's a really fun space to be in. Me and Mario are both in multi-cluster, and it's been something we both are passionate about for a couple years now.
That's awesome. So we're here to talk about we're kind of continuing our GitOps theme here. We had a show a little while back with Christian, myself, Jafar, talking about GitOps and everything. So today we're using Tekton for CI and Argo for CD to make a GitOps wonderful pipeline. So pipelines are my jam, coming from a DevOps space, and having all the code and everything, including infrastructure potentially, go through a pipeline makes a hell of a lot of sense to me, because I can add a lot of security and automation and other nitpicky things for, these things called regulations or business requirements that I can add to my pipelines and make sure my business is running effectively. So I'm excited for the show today. Let's let it rip, guys. Come on, show me what you got.
Awesome. So actually, you called it out specifically. What I'm actually going to show for my part, I'm going to show infrastructure. We have a lot of kind of upstream development work, and it requires us to have a couple clusters, and you have to kind of connect them together. And I was making mistakes. I would forget a security group here and there. I would have to chase a toddler. I would be in a meeting, and the rest of my team is stuck waiting for me. And so I was all in on Argo, and I can even show you, I use Argo all day, every day. Here is my Argo workstation. And so what happened was Argo was really awesome at deploying some things in an order that I couldn't really maintain. And so I needed a way, especially with clusters, to say, hey, I want you to deploy this cluster and this cluster over here, connect them, and then deploy this application. And with Argo, I couldn't do that. And so I really had to find something to kind of, fill the gap.
Yeah.
And so that's where, to me, Tekton came in, and it actually became something I was actually kind of passionate about, because at first I was like, Argo does everything for me. Why? Why would I even begin to entertain yet another tool? And then this scenario hit. So what I'm actually going to do is, since last stream, Christian really showed off how to set up Argo CD, I have another cluster, and I'm actually going to show you how easy it is to enable pipelines just by installing the operator, and you could start using pipelines today. And then I'm going to actually show you a deep dive into the pipeline that I use every single morning when I sign on my computer.
Nice.
So we have a clean OpenShift environment that Mario deployed for me. So to deploy pipelines, you just go to Operator Hub. Super easy. And then you type in pipelines. And it is, right here. As you see, you just click the install button and say that we want 4.4. And I like to actually use it's the default value, but all namespaces, because why not let everybody have the ability to use it? I mean, It's something that someone could use it for some portion of their job. So with every other operator, you click install. And it will be
on the operator train.
Yep, exactly. Yep.
So, if you're turning in, you're not familiar with what operators do. It is a series of, things that occur, basically. So if you want an order of events to happen and resources to come online, and then watch for things to occur, and then enact upon state changes. Like that's what an operator is for, right? Like we want everything to be done with an operator essentially, because it's declarative, first of all, so it'll put itself back into a known good state, and then it also allows you to kind of like set it and forget it, to take it from one of the 90s like infomercials, right? Like you kind of just install it and let it go, and it updates itself, it manages itself, and if it has all the capabilities, it can actually scale itself. So operators are super awesome,
especially the automatic updates. It's just, I remember, being a sysadmin back in the day, and it's like you have to DNF update everything, and it's like, no, this will just automatically handle it for you, and it's been tested, and it works.
I mean, I remember, Ansible playbooks like were a thing that I would have to make sure, like for updates on certain systems, you have to do it this way, right? Like I would have to write playbooks for updates on specific systems because they were snowflakes. Yeah, so operators I love.
I know you really appreciate the maturity in like the marketplace as things get better.
Yeah, totally.
So with the, I guess we'll go kind of cooking show style. I'm going to, since this is actually installed, I'm going to hop over to the cluster that I use today and kind of show you what's there. So once you install pipelines in the pipeline operator, you get this really cool kind of drop down in the side in your kind of task pane here, and it says pipelines. And so what I'm going to do is I'm actually going to bring it back a step and break down the pieces of a pipeline. So all pipelines are a series of tasks. We'll click the task button here to make it actually really easy. And this one specifically, all it is a task that runs kube create or kube apply-f. And that is a task in pipelines. And you think to yourself, well, that's like kind of a really common thing. I could see myself using that a lot. And I think that's one of the reasons why Tekton's kind of fun is that I can store all of these tasks in a repository in Argo CD. And then I could just share it over to Mario's namespace. And Mario doesn't have to figure out how to create tasks. It's just there. And so, your organization, your company can build out this really sweet set of tasks that can do everything in the world. And then all of the engineer has to do is take those individual tasks and then put them into a pipeline as they see fit. Mm-hmm. So it really lowers like the difficulty, and it really goes with what we're trying to do with share information between other groups.
Yeah, like the idea that like Ansible Galaxy and what is it? Operator Hub, and all the like hubs of sorts, right, where people are sharing content these days. Like Prometheus has one. I think eBPF has one. Like there's all these hubs now, and we're getting to that point where if you need to do something, someone has probably already done it, and like you might be able to just grab something, look over it, tweak it to your needs, and then it's ready for you. And like that's the methodology that you can get to very quickly with just Argo by itself and CD in the mix.
Yeah, that's exactly it. I mean, everybody's has a catalog, and even internal in your company, I'm sure that everybody has some sort of catalog. Even at Red Hat, we have Git repositories upon Git repositories of tools and documentation hubs to just share things between each other. So the next level of like tasks are actually executing the tasks themselves, and those are called task runs. As you see here, I have a task run from a couple days ago, and all a task run is just you identify a specific task that you'd want to actually run, and you provide any parameters at the time that may be required to run that task. So we'll just jump back to the kubectl create one. I can actually take this one, as you see here, run this pipeline and say, hey, for my Git repository, just run kube create against this Git repository, and it's going to drop whatever onto my clusters that I need.
Nice. So, and you're doing it in a way where you can actually substitute for environments and everything.
Exactly. And that's the really fun part, because all you do is you give the task your Git repository, your branch, whether it's master, stage, so on. And Mario's got a sweet demo of this later. That you give it the branch, and then it's going to just go ahead and apply it to that specific environment.
Awesome.
And so now that we kind of cover tasks a little bit, I'm actually going to show you the pipeline run that I was talking about earlier. And the really cool thing about pipelines and pipeline runs is you have, let's see here, I have this create 2 clusters and mirror pipeline. And when you click it, you get to actually see this really cool view of all the tasks that go on. And actually you can kind of see how they're time seriesed. So for example, on an OpenShift installation, if I were to run these 2 create clusters at the same exact time, I would hit the resource limits on the API on AWS, and it would just kill both installations. So I can build out my series of tasks here to wait 15, 20 minutes while this cluster is creating, this cluster creates, and then I have a task that will actually check those clusters to see if they're actually officially ready. And then once they're ready, they're going to go ahead and do VPC peering amongst each other. And then they're going to deploy the latest OCS storage bits. And it's just the part that I kept screwing up when I talked about it early on. I would forget in the peer cluster step when I was doing all of this manually to, open a security group. And without that security group, the 2 mirrored clusters couldn't talk to each other. So you see where the strength really lies. And the fun thing is, these are just all tasks that are going on, and you can kind of piece them together as you see fit. And if we go back to like my other pipelines that you see here, I have one for installing ACM, one for installing OCS. And honestly, all it is create a cluster and then use that kube create job that I showed earlier, kube create task. And then boom, it's going to kube apply whatever's in the Git repository depending on the path.
That's really awesome.
Yeah, so it saved me a lot of time. And I think my team appreciates the fact that they no longer have to worry about me being attentive to what I'm actually doing. And, and if I have to go chase my toddler around, they're not waiting the entire day for me to actually do my stuff correctly. And so, yeah, here's, as you can see, it's not fluff. Here is the successful run. The cool thing is, if you do fail along the way, the pipeline will actually show you what may have happened. It'll give you like a red X here. And it's just like the whole kind of story in the pipeline. So how does Argo CD tie into this whole thing? So with Argo CD, I have all of my pipelines within my Git repository rather than just applying them manually onto the cluster. So as you see here, I'm out of sync, and it's because I actually created 2 clusters and used that one pipeline run. But all of these pipelines are in Git. They're managed. I can roll back and roll forward if I mess up a job. I can go back. I could go to stage and have some really cool different pipelines. And then the one thing that I did want to show is how I was talking about the tasks earlier, kind of sharing them to other groups. So as you see here, here's just the Argo CD of my tasks, all of them, the cube CTO create one that I've showed a couple of times. I can actually take this path in Git and then go ahead and just deploy it to my other cluster. So I'll share that right now. So we have the cluster over here that we actually installed Tekton on just a little bit ago. I'm going to create a namespace called test. And so we'll go back to Argo CD, and we're going to actually create an application, and I'm going to share all of my tasks over to this new cluster. So we're going to go site 2 tasks. We're going to do an automatic sync policy. We can do prune resources when it comes to tasks itself, but I strongly suggest against pruning your pipelines. And the reason why I say that is you'll have a pipeline run going on, and Argo CD would be like, that's not supposed to be there. Why are you doing this? And it's gone.
Goodbye. Yeah.
And you might ask yourself how I know this. I was working the other day and I couldn't understand why my my pipeline runs just kept disappearing after 30 seconds.
Yeah. Oh man, that is a hard lesson to learn. That yeah. Oh boy. I mean so I have done very similar stuff with almost every automation thing I've ever done, right? Like, wait, I created that thing. I modified that thing. Why is it now gone? Oh, I have this other automation thing maintaining state over here. Duh, you have to pause that. It's like this checkbox is that pause button. Yeah.
And it's like, it's sad because it's like the exact thing that I love Argo CD for.
Right.
That kind of overbearing parent that's going to go to my cluster and be like, you created this.
You don't need that.
Get out of my cluster. So yeah, it really caught me. It definitely caught me. So yeah, so going back to sharing out these tasks to yet another cluster. So I have my Git repository already loaded. See here, I specify my Git repository. It's called Sleepy Admin because it goes back to what I was saying earlier, where I was forgetting to do things a few times. So it seemed like a good name. So I specify pipeline and tasks. Let me actually make sure that that's the right path. It's actually task. And then I'll specify the destination cluster. This is Twitch. That's the name of the cluster that actually loaded in.
Sweet.
And then I specify the
people make resources
test.
just for Twitch.
And create. And so it'll go through the syncing process. It says we're out of sync. And now if we jump back over to our test cluster, our test namespace, I go over to pipelines and task, and then they're all there. And so Mario, that engineer, anybody that gets this cluster now has these tasks that are in Git, deployed by Argo CD. So anytime I come up with this new crazy config creation or image creation thing, it's automatically shared with that engineer and they can use it today.
That's amazing. That's like such a great way of managing stuff. Right. I mean, anything, right? Like the principle of GitOps is there's a source control management piece at the center of it, right? Like all operations happen through a Git something. So if a Git something occurs, it has a hash normally, and that hash it becomes somewhat of an audit log. So you can see where I'm going with this. Source control management or Git or anything at the center of this that has something like that Git capability of hashing all the changes and everything is quite fun and helpful to have at the center of this, because then you can share that around and you have all the power of Git and everything else along with that. So now that you can say, all right, I have this Argo pipeline, I have it set up, I can now share this whole repository of pipelines with all my team, onboarding becomes a hell of a lot easier. I mean, onboarding is like a couple clicks and oh, here you go. We've created an account, wherever you need to create an account to add people to your cluster, and then you have this repo done.
And that is exactly why I'm on Team Argo CD, and I think Mario is too, just because it's all about enablement, and you can enable someone to be successful very, very quickly. There are no real walls and nothing that stops you from kind of doing what you need to do.
Yeah. It's pretty nice. I like it. I mean, there's obviously, a lot of competition in the space, a lot of movement in the space right now, but yeah, like it has that very much like Ansible feeling to it of, low barrier to entry, nice getting started kind of feeling, nice experience kind of feel.
Yeah. And even comparing it with Ansible, that's where, Tekton, I think, kind of ties in too, because back in the Ansible days, the nice thing is it goes in a series, a maintainable series. Mm-hmm. And I think Tekton, bridges that gap with Argo, that it gives you that maintainable, okay, this thing. And then, you have a specific state at the end of the day.
Yeah. And somebody, Jay Warnica, asks in chat, where does Red Hat Advanced Cluster Management fit in? And that's a very legitimate question. We, have a lot of opinions within Red Hat of how to do things, right? There's no one true way of doing anything really when it comes to cloud native ecosystem type stuff, right? Like there's a bunch of different suggestions and the thing that works for you. So ACM comes in and manages clusters and keeps configuration and state managed per cluster, but it also adds that application management layer and then a security and compliance layer that is just completely missing from any of the GitOps tooling right now, as far as like just plug and play security policy applying. Right now, you can build that stuff today, and I think some of it is out there to an extent, but it's not nearly as versed and in depth policy wise as ACM is. And then application management with ACM it's very similar, I feel like, to kind of doing things with Argo CD. But it is slightly different way of doing GitOps kind of thing, right? Like there's more than one way to do GitOps. It's just like there's more than one way to do DevOps, right? Like it's what's working for your org that makes things go is what you need. So that's kind of where Argo, like that ease of use, comes back in. And Christian put in chat perfectly, like the strengths of both ACM sorry, bootstrapping, policy compliance, Argo CD, syncing applications and workloads. That like bootstrapping your clusters, policy, applying them, compliance, making sure your apps are all good. That's where ACM really shines. Argo CD shines, that's syncing applications and workloads. So they both have their proper place in the fold, right? And it's you can do the same things with many different tools, right? Like it's we were just talking about this before the call started, right? Like it's back to like Ansible, Chef, Puppet. Which one do I want to use, right? Like which tool do I want to use inside the tool chain? And it might in some instances be 2 or 3. Who knows? It just really depends on your infrastructure and the systems you're dealing with at times. So that's really kind of the big thing for me, is that having the options out there is amazing. Right? Like we have choice. This is great.
I know it's what a time, because there's not just one stack that you have to fit your workload into. There's not one forced thing, because I think we all know that if there would be one forced product, someone would fork it and create it in a way that suits them. So you nailed it completely, because that's how we kind of feel. It's whatever kind of works for you at the time, whatever you feel comfortable with. It's been kind of how we've been working. And one thing I will say, actually, I know Christian covered it in chat, but for the cluster deploy pieces that ACM actually does, going back to my other screen here, you see that I'm in the project of Hive, and there is an operator and operator hub called Hive. And what Hive does is it handles cluster deployment. It's an OpenShift repository that maintains Hive, but Hive maintains the cluster deployment, will deploy your resources for you on many of the cloud providers, and I think bare metal as well. And the reason why I mentioned that is that Hive is the kind of upstream to the ACM deployment tools. So cluster deploys within ACM use that Hive and specific cut releases that are supported to do that cluster deploy. So kind of how I'm bringing this all back together is we're doing a bunch of tools to kind of mimic on a smaller scale what ACM does. And so ACM just, it has, I guess, everything. And you described it completely. And the only piece that I'm actually not covering in here is policy. But you see a lot of these tools that we're actually using are in ACM, but it just whatever we're comfortable with. And I think Mario and I have spent so much time staring at the Argo CD console that this is just where we're super comfortable.
Yeah, like I understand the comfortability level and the willingness to just kind of like, yes, this is very nice. I like this. Let's go along with this, right? Because it does give you that, oh my gosh, I was just productive wow, like kind of feeling. So yeah, like it is that Ansible feeling all over again. I feel like I keep saying that, but I need to reiterate it because it is very much the same kind of feeling.
Actually, you described the first couple times I used Ansible,
and
yeah. That's how it completely relates. It's like it works and it's done correctly, and yes, you're happy.
Yeah, you're very happy when that like Ansible playbook finishes, changes, zeros, and everything's beautiful and everything's just set. So yeah, it's very much that Argo CD way, that Ansible way, that Flux way, whatever way you want to do it. It is the way of GitOps. Like as long as Git is at that source, and as long as you are making it as shareable and as easily accessible to others as possible, you're doing it right.
Yep, that's exactly it. And then actually, you remind me of one more kind of infrastructure admin typey thing I really want to kind of show off. I luckily have time to, but kind of how we just were talking about everything in revision control. I want to actually show like one last thing of managing who has access to clusters in all of my authentication via Git. And the cool thing is Argo CD can actually drop that into place. And so I'll go ahead and create like a last new app here. We'll call it Twitch Auth. And we'll go default project, automatic sync. And this time we want to prune, because if there is anybody that is in this cluster that is not supposed to be, and they make themselves cluster admin, I want them booted. So,
right.
So going back to my repository, and you'll see creds, overlays, and Twitch. Going to the repository, I'm actually going to show that off if I can get it to work. There we go. So I'm using Customize right now, and I know that Christian actually covered Customize in the first talk, but I have, as you see here, about 6 different clusters that I'm applying authentication to. But all of these have a unique GitHub secret, a GitHub authentication token. But from one single location, I'm actually managing all the admins within my clusters.
Right.
So awesome. I can actually apply this to all 6 of those clusters. If I get a new administrator, I add them to the list of admins here, cluster admin -3, and then that user has access to all 6 clusters just by using Argo CD and having Argo CD actually manage our authentication.
That's awesome. I mean, like, this is actually a playbook that I wrote one time for Duke University. Like exactly this. I wrote a playbook to manage users across their systems. Like, and it looked almost exactly the same. That's pretty cool.
Yeah, it's fun how you can see how it just applies to Kubernetes and
right
back to what you've done in the past. I mean,
and the wording is the phraseology is not like super, hard to pick up on, right? Like a task is a task. Things just do what they're supposed to do, right? But when you're doing these things and you're like, wow, this just works, like you have to understand that this is an abstraction layer too. So like having to understand those underlying pieces kind of matters as well when things go bump in the night.
That's exactly it. Yeah, and the cool thing is this thing, hopefully Argo keeps you from too many bumps in the night.
Yes.
I think the one thing that I really like about Argo is the fact that it saves me from causing myself pain. I think I showed a few years ago at Lisa, I actually deleted the entire deployment, service route, everything relating to the application that I was showing on the screen. And Argo CD actually fixed it faster than I could like begin to panic that I accidentally deleted the wrong stuff.
Wow. I mean, that's pretty awesome. I mean, panic is one of those states you never want to be in as an admin, right? Because you make mistakes more, right? Like they pile on top of each other. So to have something to come back and say, oh, I fixed your mistake for you, sorry, go about your day, is very, very comforting.
That's exactly it. And then, so we already see that the authentication's actually already dropped on this Twitch repository. And then, we have credentials there. And then just to kind of show off how easy it is to to add admins and what that looks like. Mario, congratulations, you have a new job. You're now the admin of my cluster, so congratulations.
Golf clap.
Yeah. If I can remember your GitHub auth, that will be the key to how much access you actually have or someone else has. So I'm going to go ahead and commit this change. I know that this is completely not what you're supposed to do, commit automatically to master, but just for show, I'm going to go ahead and make Mario cluster admin 3, commit the changes, and then we'll go back to Argo CD. And we're going to look. And as you see right now, we only have the 3 administrators that we have today. I'm going to force sync it just because I'm impatient.
Yeah,
and
like
I made
Uh-oh.
What did I do? Okay. I think I made a YAML issue. All right, let me go back.
YAML strikes again.
Yeah,
I need like a sound effect for YAML errors, right?
This is the fun of doing things on the fly.
Dude, this is like the best part of this whole medium is when stuff breaks. Like when stuff breaks, I love seeing how people troubleshoot it.
So I think this one was easy. I'm calling it easy now. I think it was just 2 spaces that were in front of the divider here. So let's actually go back and see if I did manage to fix it or what error I caused this time. There we go. Okay.
Nice. Okay, cool.
And so the live manifest has landed. Mario, congratulations on your new responsibilities of managing my clusters. You've been picking up the pieces that I break for years, so might as well just keep doing it. So with that, I'm actually going to let Mario go ahead and show off his really sweet CI/CD demo using both Tekton and Argo. It's an application and it goes through the entire application process. So I'll let Mario take over and describe it.
Okay, so let me share my screen really quick. All right. So you should be able to see Firefox browser.
Yep.
Give me 1 sec so I can log in here really quick. All right. So before starting with the demo, I just want to say that all the demo that we're going to show today, it's available on this repository. So if you want to have a look or even running on your own environment, you can go here for the repository and you have the instructions to run it on vanilla Kubernetes, let's say, as well as on OCP. So feel free to do it. And if you have any issues, we are happy to help you. So that's it. I will paste the link in the, well, I don't know if I can paste the link in the tweet chat, but let's try. If anyone wants to see it, okay, should be ready. All right, so let's start. Before starting, I want to introduce 2 repositories that we will be using for the demo today. So we have a small application which has a small API, is written on Go, and what we want to do today is whenever a new commit hits the master branch of our application, we want the application to be built, the test to be run. Then if everything goes okay, we want a new image being pushed to the registry, and that should be deployed on the stage cluster automatically. So the users can start using it on staging, and then we will have a different process for promoting the image from staging to production. So we like to call this demo from code to production because we are showing all the way since you write the code, since the new code is deployed to production environment. Okay, so this will be the first repository. As you can see, very basic repository, just 1 branch, nothing else here. And then we have the CI/CD repository. So I like to have different repositories for my application code and the CI/CD for that application. That's There's no standard around this, so everyone can do what fits their best. In my case, I usually use two different repos, and in one repo I have the application code, and in the other repo I have the CI/CD code. So as you can see here, the name repo is the same as the application, but we are adding CI/CD. And let me explain the different branches that we have here. So we have a branch for all our CI code. So in case that, as Ryan showed, if we lose our pipelines, or if we want to deploy these pipelines to a different cluster, we just need to point ArgoCD to this branch, and all that stuff will be created automatically. So we are not creating it manually every time. That's the CI branch. That's all the Tekton files that we will be using in our pipelines today. And then let's jump to the CD branches. So let's start by the stage branch. So we are using Kustomize as well. Kustomize was explained a few weeks ago. Christian did it. So what we have here today is two branches, stage and production. In each branch, we have the different files that are different for our environments. So let me explain this. So we have different environments, but in those environments, it's possible that some files are common to all environments. For example, I'm thinking about a service, for example. If you have a service which is called reverse words, in this case, probably that won't change across different environments. But then if you're using an ingress or a route for accessing your application, that will likely change between environments because you have different ingress domains, as well as, for example, namespaces. If you're deploying to production, maybe your namespace wording ends with production, and in a stage, it ends with a stage or whatever. So we have the two branches here, and then for all the common files, I like to use a different branch, which is called config in this case. This is really basic. So we have the basic deployment for our application. It's a standard Kubernetes deployment, which points to an image. In this case, it points to the latest tag for our image here. And then we have environment variable, which is called release. In this case, you can see that it's set to base release. And then the customized file, really simple. It just points to these two resources. And now the cool thing is that if we go, for example, to stage, Kustomize allows you to point to a branch in our repository, even a different one. In this case, we're pointing to this same repository, as you can see here, but we're saying, okay, this customization will get the basis from this Git repository using the branch config. That means that Kustomize will get the namespace, the deployment and the service from the config branch, and on top of that, we'll add some things. As you can see here, we're adding a namespace and an ingress. We will look at those later. And on top of that, it's patching the deployment. So let's see what that will look like. So the namespace, we're just using this namespace here, reverse words stage, for our stage application. The ingress, we are using the correct ingress domain for our staging cluster. And then in the deployment, we're just updating some things. So we are updating the image that we will be using. As you can see here, we are not using latest tag. We are using commit ID. We will explain this later. And the release name is being set to a stage release rather than base release. So that's how it works. The same applies for production, but we use different commit IDs and different release name. So that's the important thing here. So these two repos is where all the magic happens in Git. And now I want to explain the different pipelines that we have in our environment. As I said, we want that whenever a new commit hits the main branch in our application, we want that new code to be deployed to the different environments. First the stage, and once the stage build is tested and it's correct, we want to promote that build to production. So this is how it works. We have our developers here that will push new code to GitHub in this case. Then in GitHub, we have configured some webhooks. We will have a look at those later. But basically, in the application repository, we have a webhook that says that whenever is a new commit hitting the main branch, we want to send a webhook to a given URL. That URL is being managed by Tekton in this case, and Tekton will basically go ahead and run the pipeline, which will build our code. We'll link the code first, then we'll run the test, and finally we'll build the code. And when all those 3 steps happen and are correct, it will create a new image, and that new image will be pushed to the Red Hat.io repository, registry. And at this point, we will have a new image ready to be used and ready to be deployed to our stage cluster. In this case, our stage and production cluster is the same one. We are just using different namespaces. All right, so we have the image. Now, the next step is the pipeline will go ahead and modify the deployment file in the CI/CD repository. So that means that a new commit will be sent to the CI/CD repository. And in that CI/CD repository, we have another webhook, which points to ArgoCD. And what will happen is that when ArgoCD receives that webhook, ArgoCD will go ahead and deploy the new image to staging. That's the way that we have to go from code to the stage environment. And then we have a different pipeline for promoting the image. In this case, is simpler. That pipeline could be run automatically, or maybe after some PR is merged in some repository. That's up to you. In this case, we're running the pipeline manually. So when we feel that the stage build is stable enough so it can make it to production, we as developers will run a pipeline on Tekton, and what will happen is that Tekton will read the stage image configuration, so it will go to the CI/CD repository. We'll see which image is being used in staging, and we'll configure that same image for production. Again, when that happens, that will trigger a webhook, and ArgoCD will receive that webhook and will run the deployment to the production environment, or in this case, to the production namespace. So that's the workflow. I don't know if there is any question in the chat, but we can cover the questions if there is any. Otherwise, I will, okay, please.
I don't think there's any questions in chat specifically to this, but yeah, like the idea of it being linted and tested and everything else is awesome. So yes, very, very important, everybody.
All right, so let's start. So we have here a clean ArgoCD deployment. So the first thing that we need to do is connect our repository. We are using HTTPS for connecting to our repository. And we need to connect to the CI/CD repository because this is where we have all the YAML files that we use for deploying the application. So this is a public repository. We don't need to provide any secret or TLS or anything. So let's click connect, and we should get the repository loaded in ArgoCD. So here we are. Okay, next thing is creating our applications. So the first one, I'm going to create it using the web UI in case there's someone in the audience that haven't seen Argo in the past. So this first application will be the staging application. As project, we are using default. Then the sync policy, we are using automatic. Although we are using webhooks, sometimes the webhooks can be lost. So for some reason, the webhook is not received. And if you don't have an automatic sync policy, what will happen is that your new build won't be deployed. In this case, if we receive the webhook, the synchronization will occur at that exact time. If for some reason we lose the webhook, ArgoCD every 3 minutes, if I recall correctly, will run the synchronization for us, so we don't have any missing deployment here. Then pruning. Sorry.
I like that you're more paranoid than I am. That you have 2 methods to deploy your application just in case.
Yeah, just
Extra
in case.
paranoia.
Exactly. So as Ryan suggested, we don't want to brown resources for this example, but we want to have self-healing, which means if there is something in the Git repository which is not present in our cluster, we want that fixed for us. So let's click that. Then we will validate all the YAML that we are creating. And now we need to select the Git repository. So we are using the CI/CD repository, and here comes the thing. We are using the stage branch for deploying this application. And the path is the root folder for the repository, since we are not using folders. That's pretty much it. We need to define the cluster, which in this case is the cluster where ArgoCD is running. That's why you see this cluster name, which is the Kubernetes default service. And then as destination namespace, we are using this one, which, by the way, we are creating with ArgoCD. And now I think that we are ready to create, and that will start the application deployment. So we can click here, and we should start seeing things being created. All right, so we can see here our application. The application has created a namespace, a service. The service created some endpoints. Then we have the deployment, which created a replica set, and the replica set is creating a pod. And we have so we are using ingresses objects. And what is happening is in OpenShift we use routes, but if you create an ingress object, we have a controller that will automatically translate that ingress to a route object. So as you can see here, we created an ingress object, and we are getting a route created automatically. So if that's correct, we will be able to access our application. Okay, so we have here our application. Let me make this a bit bigger. Reverse word release, a stage release, and the application version is 0011. Okay, so now I'm going to switch to the command line in order to create that second application. So we are now in the command line, and we are going to use ArgoCD CLI to create the second application. So let me copy the command really quick. Again, we are using the default project. We are naming the application reverse roles production, same Git repository, same destination server, and then the same namespace, but we are using the production branch this time. We are not using stage, we are using prod. Then we want self-healing, and the sync policy, we want it to be automated as well. So as soon as this is created, we will go back to Firefox, and we should see the application being deployed. So, okay, we can see here that the pod is being created. Let's wait and let's access the application so we can see what differences we have.
So if you don't notice the spinning wheel on the right-hand side there, you want to, there you go. Yeah, thank you. So I mentioned in chat, the ingress to route conversion thingy is pretty nifty. I think that's one of the cooler parts of that whole process there.
Yeah.
And
so
voila.
you can use that for, so your application, you don't need to have different YAML objects for deploying on Kubernetes in OpenShift. So at the end, OpenShift it's Kubernetes, so yeah, you can use the same objects. All right, so here we have the production release, and as you can see here, instead of 0011, we are running 0010. We don't care about that now. So we just know that the application is deployed. So now is when we are going to start looking at the different configurations for the webhooks. All right, so let's go back to the application repository. So we have here in the settings page of our repository, we have a webhook. And if we go here, you can see that we have this webhook, which is pointing to the event listener that we created on Tekton for this application. So what will happen is that when new commits hit the main branch in this repository, we'll send the webhook to this URL, and that will be received by Tekton, as I said in the past, and will run the pipeline for us. automatically. And the same thing applies to the CI/CD repository. So if I go here, settings, webhooks. So one thing that I want to mention is that with Tekton, you need to create the webhook endpoint. So you need to create an event listener, trigger binding, and so on and so forth. You will get that URL, so you can start running your pipelines using webhooks. With ArgoCD, that's configured out of the box. So you will get this API/webhook endpoint by default, and that's where you have to send the different webhooks. And the way that Argo consumes the webhooks is that when you create an application in Argo CD, you are defining a repository as well as a branch and a directory or folder inside that branch. When the webhook is sent to the Argo CD API, the webhook will have all that information, which repository it comes from, the branch, the folders, everything. And Argo CD will read that information and will know which application it has to synchronize. So if you send a webhook, you're not synchronizing all your applications. You are just synchronizing the applications that are affected by that change. That's pretty cool, in my opinion. And that's pretty much the webhook configuration that we have here. So the next thing that we have to do is, well, I haven't shown that, but we use secrets in our webhook. So we don't want that anyone without, so just knowing our URL can send us a webhook and trigger a pipeline in our cluster or deploy a new version of our application. So use always secrets for triggering your webhooks. That means that we need to provide that secret to different applications, so they validate that the webhook comes with that secret. And now I'm going back to the terminal, and I'm going to configure that secret in Argo CD. As you can see, it's a really secure secret here. We just need to patch a secret and add that secret data to the GitHub webhooks here. So that's all we need to do. And now it's where the cool thing starts. So first, let me go back to the OpenShift console. As Ryan shown before, we have these cool pipelines integration here. As you can see, we have two pipelines, the one that I mentioned for building the application and the one for promoting the image. So now, as you can see, we don't have anything running. So next thing that we need to do is commit some code. So so we trigger that that pipeline run. Okay. So what happened here? So I changed my directory to the reverse words application repository that I have cloned in my local environment, and I'm just bumping the application version. So the application version was 0011 and now is 0012. That's the only thing that we changed. So now we commit that that code and we push that to origin. And again, this is not the way of working. Usually when you run all that stuff, you want to use PRs and you want your colleagues to review your code, but this is just a demo, so we are doing it faster.
Yes, please create branches. Please use PRs.
Exactly.
But for the sake of a demo, I don't need to approve something that he can just do on his own.
Exactly. Okay, so we have committed that code. It hit the main branch, and as you can see, we have a pipeline running now. So what we can do now is we can go here, and we will see the different steps happening. So this could take a while. It shouldn't take that long, but again, maybe 5 minutes or so. But we can explain what is happening. So now what we are doing is we are linking our code. So in case we are using some code that is not, let's say, writing the standard way of doing things, or we are using variable names that doesn't match the standard style for the Golang code, So we will get those errors here. This is like, okay, you are writing your Golang code as someone will expect to be written, something like that. And that's the first step. Next step will be running our test. So we have some tests defined in our application repository. So this task will run those tests, and in case any of those fails, we will see the failure here. So now it's cloning the repository, getting the requirements, and now it will run the test.
And the cool thing is, you know, that right as you committed that code, that webhook like immediately fired and kicked off that pipeline. So there was no like lag and waiting. And when you're impatient and all caffeinated like me, you really appreciate when that hits.
Yeah, it's the moving at Kubernetes speed is what I like to call it, right? Like it sees the event and it fires and it starts working, right? Like it's moving at Kubernetes speed, doing things with operators and with Argo CD and proper pipeline type fashion is going to keep you moving at the speed of your infrastructure, and your infrastructure will not be your bottleneck, right? You will be the bottleneck.
Exactly. All right, so this is awful. We don't have even the half of our code we test, but again, all tests that we have at least have passed. So now what is happening is we are building the container image, and then when that container image is built, we will be pushing it to the registry. And in the meantime, I want you to look at this file really quick. So the states deployment file. As you can see here, we have this SHA here. This is a commit SHA. So the way that we are tagging the releases is when that release is created by the pipeline will read the latest commit ID that hit the main branch. So let me show this. So as you can see here, we have this commit ID that you can see AC57. And at this point, it doesn't match because the file is not updated yet. But the idea is that the pipeline reads that commit ID and uses it as the image tag. That way, you can easily know which code is included in that container image. So you just need to go to the Git repository, look for that commit ID, and you will know which code actually is in that container image. So let's keep that file open in the background, and let's go back to our build. Let's see something. No, okay. Okay, this is still building.
Build with the build. Uh-oh. Is it still building or?
Yeah, let me.
Okay. Sorry. I didn't see the thing moving there.
Yeah, I'm looking at the pods now in the terminal, and as you can see here, we have this not ready pod, which means that something is happening, but it's still not done. So let's go back to Firefox, and eventually we should see the log moving. Message error retrieving request logs. Let me go back to the terminal. Let's see if we can see what is happening here. We could use a TKN command line as well.
Mm-hmm. Someone actually just mentioned in chat that they think the TKN CLI is so much clearer. So here we go.
Okay. we will use that. Okay, it's still running.
Oh, it's still running. Okay.
Yeah. So for example, the TKN, we are using the namespace, CI, and then we could say, okay, pipeline this. We will get the list of pipelines that we have. This is the same as in the web UI. As you can see, we have a pipeline run. So next thing that we can do is pipeline run list, and we could check the logs as well. The cool thing about this is that you don't need to jump through the pod containers to see the logs of the current step. TKM will do that for you.
Nice.
Okay, so let's see if that finishes. Sometimes it takes a bit, but hopefully it won't take that long this time. We can, if this for some reason hangs, we can just run the pipeline again, but this usually works. So this is the first time that I see this taking that long. The class is new, so maybe there are some images that needs to be downloaded and so on and so forth. So let's see. Okay, I can see the log moving on the, okay, here we go. Yeah. We can see the log moving in the terminal and in the web UI it's moving now as well. So I want to mention one thing here. We are using for this demo one tool that is really cool, and I would like to thank Kevin for helping us with this. This is a small tool called image hooks, which I guess it's pretty cool because you can actually say, I want to update this file in this repository, and it will basically do that, and it works really well. And you can use that tool for updating a file without user intervention, or you could, as we will see in the next pipeline, open a PR. So someone needs to take care of that. So as you can see here, that's the image hooks tool, which went to the stage branch and updated the deployment file. So I'm moving back to Firefox. We can see that the pipeline now it's all green. We can see all the details here. And then if I go back to the deployment file, now this should have changed. As you can see here, we are now using AC57, which is the commit ID that was created when we pushed the new application version. So I will paste the links to the image hooks tool later, and we will see a different tool if we have time as well. Because we have talked about webhooks, but what happens if your environment is not published to the internet? So we have you covered. So we will see that. We will see that later. All right. So now we should have the new release deployed in the States. As you can see here, that was synchronized because an automatic update image was updated, which that's the commit message created by the image hooks in application tool. Sorry. So as you can see here, we have a new replica set, the recent issue that created a new pod, and if we connect to our application now, you can see that we are running the new release 0012. So now we can go back to the production environment and make sure that environment is still 10, so everything's good. So now let's assume that we have tested the application, that everything is working correctly. So now we are ready to move to production. So how do we do that? All right. So we could use the OpenShift UI to create a new pipeline run. But again, let's use the CLI because I like the CLI. And some people in the chat as well. So that's a good excuse. Okay. Let me explain what we are doing here. So we have this pipeline, which is called promote pipeline, and we need to define some resources and some parameters. So for those that don't know, Tekton supports resources and supports parameters. Long story short, we are using resources for defining the Git repository where we have the CI/CD code, and then we use resources in the other pipeline to define the QA repository that we use. And then we have some parameters. We need to define the path to the deployment file that we will be updating. Again, this will run image hooks, and we will say, okay, we want this file to look like this, but this time we don't want to update the file directly. We want to open a PR, and so we can review it. Then the stage branch for our application, sorry, for our CI/CD repository is a stage. And then here we're defining the stage app URL. This is kind of for testing here, but again, you could have some acceptance test, or call it what you want, some test that you run before actually going to the repository and update the file. So let's say that you want to test that the API is working correctly, that returns the proper codes and runs as it should. You could have all that stuff in this pipeline, and at the end, just modify the file. And for that, we are running an OC command to get the proper route. So that will create a new pipeline run. If we want to see the logs here, we can with tkn.
Come on. You can do it. Pick up that event. Come on, Trigger.
So this is something that I faced several times. The first time that you run a pipeline, it needs to download the different images just by the task, right. And it can take a while to create the pods.
No, I know. I always like to encourage my commands to execute, right? Like they're people. That's just me. So like when you see me like come on, you can do it. Like that's me just hitting enter on something.
I mean, I usually go the route of furiously checking pod logs is usually my strategy. It's like
right to make sure like yeah, you didn't screw something up. Yeah. No, I just wait for the output. I'm patient. Then I go look.
Yeah.
I mean, I can't tell you how many times I've tried to ask for logs of a container creating pod.
Oh, well, yeah.
I feel like Kubernetes at some point just be like, seriously, stop. And it's just going to post that error message.
Take your medicine. Stop.
Okay. So what happened here? We have the curl command to the stage application, so we can see that everything is working as expected. We are seeing that we are using the 12th release in the staging, so that's okay. And then image hooks actually went ahead and opened a PR for us. So if I go back to the Firefox browser, what will I see? So first off, we have the production application here. As you can see, we only have one pod. Everything is still the same. Release 10. And now, if I go to the CI/CD repository, we should see a new pull request being opened by myself, because I'm using image hooks uses a token. I'm using a token acting as myself. So let's see what happened. We have a new commit here, and then what changed? So we can see here that we changed the deployment file, and we are now using the same release that we have configured in a stage, AC57, if you remember. So let's see how fast ArgoCD is. So I'm going to click merge pull request, and as soon as that gets merged, we should see ArgoCD taking care of that stage. Let's see. All right. Sometimes it takes a bit to refresh the web UI, but we should see that happening.
I definitely got to say, Mario, like the first time I remember you showing me this demonstration where stage gets built, it gets tested and deployed, and then the PR is automatically created. I realized that I could probably be replaced at some point by a set of Mario scripts.
That's when you know you've achieved automation.
Okay. So sometimes that happens. I don't know why, but the web UI like hangs and it's not being updated. But as you can see, we haven't clicked anything like synchronize or anything, and we can see here that the application was synchronized because the pull request was merged. And now we have a new replica set, which is running a new pod. And as you can see here, if we go to the production release, application, we are now running the 12th release. And if we go to staging, we're running the 12th release as well. So that's how we went from code to production, actually. And now that this is the basic demo, let's say, and now I want to introduce a cool thing that we have been testing this week, which is all right. So you are using webhooks, but what happens if you don't have your cluster not connected, but you cannot access your cluster from the internet, so you cannot receive the webhooks. All right, so Kevin again created a tool which is called Tekton Pooling Operator, which basically it's a Kubernetes operator where you say, okay, I want you to monitor this Git repository, and whenever a new change happens in a given branch, I want you to run a pipeline. So the idea is kind of the same like with Evan listeners, but this time you don't need to have anything published to the internet. So let's deploy that operator really quick. In order to do so, I'm going to create a namespace, which is called Tekton Pooling Operator. I'm deploying the operator in that namespace. So we have now, we should have a pod running. It's created. Now we have deployed the operator in this namespace called Tekton Pooling Operator. And if you want it to be able to create pipeline runs in a different namespace, you have to provide that access. Otherwise, you could deploy the operator in the namespace where the pipelines run should be created. But I feel that like I really like this way of doing it, because you can have one pooling operator that can be used from different namespaces. So you don't have to deploy it more than one. And that's all right. So in order to do so, we create a cluster role, which basically allows to create pipeline runs, and then we assign that role to the in the namespace reverse worst CI, which is the namespace where our pipelines will be created. Our pipelines runs will be created, and we are assigning that role to the service account used by the pooling operator. So now that we have that, we need to do something else, which so sometimes you need your pipelines to use secrets. For example, in our building pipeline, we need to provide a secret so it can push to Quake. It needs to authenticate in order to be able to push the new image to Quake. So that happened under the hood, and we have that defined in our CI files. But with this pooling operator, you still cannot define secrets for a specific task. So in this case, we are giving the default pipeline service account access to the Quake user pass secret, which has the Quake credentials. All right, and now let's jump to the cool thing. So what I'm going to do now is I'm going to create a repository object. Let me go over it. So this is a new CRD that it's implemented by this pooling operator. So it's called repository, and you need to define the URL for your repository. In this case, we are watching the application repository. Which runs are we using? In this case, we are looking at the main runs. Which frequency? We are just watching every minute if anything changed. Now the Git repository type, for example, you can use GitHub or you can use GitLab. And then the pipeline that we are running. In this case, we are running the pipeline which is called reverse worst build pipeline in the reverse worst CI namespace. And as I said, we are using some parameters. We are using an image tag as well as a repository, the commit ID that we will use as an identifier. And then we are defining a repository URL that will be used by the pipeline as well. So now, again, we are using some resources in our pipeline run. We are using a resource for our application Git repository. So we are defining here the Git repository. As parameters, we have a URL which points to the parameter, which is the repo URL. This is actually, so the polling operator will take care of that, and you will have that information available for you. So you don't need to, if you have defined the URL here, you don't have to define it another time. You can just use the information from the spec. And then we have the revision, which will be which branch we want to clone, so to speak, or which branch we want to, well, clone. In this case, we are cloning it. So we have the commit ID in this case, and then the application image, as I said before, we are pointing to the GUI registry. So when I click create, what will happen is that if we go back to the bots, oops. If we look at the logs, we should see that the first time that you configure the repository, it will run the pipeline, but then if it doesn't detect a change, the pipeline won't run. So it basically stores the latest commit ID in the status of the CRD, and if that changes over time, then it knows that it has to run a different pipeline run. So we have here that the pipeline run has been launched. So what I'm going to do is I'm going back to Firefox, and we should see that new pipeline running here. Okay, so we are not going to wait for it to finish. It's just so you know that you have that possibility. So you can use that tool if you don't have your clusters exposed to the internet. And then that will be it for the demo. But I have another thing that I want to mention, and is that for this application, we haven't used secrets at all. Sometimes we get questions around what should we do with our secrets. And again, you shouldn't push the secrets to Git because, as you know, the Kubernetes secrets are not secure, so they are base64 encoded and can be decoded really easily. So we are going to see sealed secrets today, and that's a way of doing things. There are other tools out there that you can use, like, for example, bold secrets, and I know that there are others. But today we are just showing a basic use case of sealed secrets. So again, let's go back to the terminal. Let's clean the output. And I have downloaded the KeepSeal CLI, which is the tool that you use for seal your secrets. But before doing that, we need to deploy the sealed secret controller in our cluster. So in order to deploy it, you just need to load it in kubesystem. It uses a privileged pod. Again, it needs to unseal secrets on all the namespaces on your cluster. So it needs to be at this point. So what we are doing is we are creating that, and the way that it works is it uses public and private keys to encrypt and decrypt your secrets. So you have a private key in your cluster, and you encrypt your secrets with a public key, and then the controller is able to decrypt the secrets that you encrypted with the public key. That's basically PKA infrastructure. So yeah, we should have the deployment, the controller running. Let's see that. Okay, we have it here. So now I'm going to change my directory to the CI/CD repository. I want to stash everything. If I have something changed, I don't know. We don't have anything. Okay. So now I'm going to check out the states branch, because we are creating our secret in the states environment. We need to get the changes that we did, which is the deployment file that we updated in the pipeline. Now let's create a basic secret. So what I have done here is I created a secret called my test secret, and I added a username called admin and a password called very secure. This is being run in dry run mode, so it's not being created on the cluster. I want the YAML output, and I'm relating the output to this file. So now here I have a secret. All right, so let's see what happens with standard secrets in Kubernetes. So let's say that you push that file to your Git repository. Someone has access to that repository, and that person shouldn't have access, but for some reason it has access. He or she has access. So let's see what this secret is. So let's see what is the password. I'm sure anyone knows this at this point, but you know that you can see that we have decoded the secret. So now we have the plain text password. So that's something that we don't want to happen. So how do we fix that? So we can use kubectl. So again, we're using the kubectl CLI. We are saying by default kubectl outputs the secrets or the Kubernetes manifest using JSON format. So since I'm using YAML and I find YAML more human readable, I want the output to be YAML as well. As an input, I'm using the decrypted secret, so the standard Kubernetes secret. And as output, I'm using this file, test secret sealed, that will be created in the repository directory. So what happened is that kubectl CLI, using my Kubernetes credentials, connected to the kubesystem namespace and recovered the public key. So it encrypted the YAML file with the public key. So now if I look at the sealed secret, you can see that instead of data, we have encrypted data, and the password now is longer. So let's see what happens if we try to decode this information here. So we are getting a binary output because this is not base 64. This is encrypted using a public and a private key. So this file now it's safe. We can push it to our repository. So let's say that we want to include that in our application deployment in states. So first thing that we need to do is edit the customization file. We are adding a new resource here, test secret sealed, as you can see here. And then if we look at the Git status, we will see two modifications, the customization file and a new file, which is the test secret sealed. So we add all of them and we commit the changes. And as soon as we do that, we should see the application being deployed on ArgoCD. Let's see. Okay, you can see here, I'll see the secret and look at what happened. So ArgoCD detected that sealed secret, my test secret, and it created the Kubernetes secret. So let's go back to the terminal. And here, if we go to the states namespace, you can see that the secret was created by the sealed secret controller. And now this is something that our applications can use. So our applications will be able to decode the secret. Okay, we have created the secret. And now, again, to emphasize, if we go back to the CI/CD repository, now we can go to the stage runs, and we have our secret pushed to the registry. But even if people have access to this file, they cannot see its content because it's encrypted. So I think that that's something that can be used for production use cases where you need to, where your application needs secrets, and it's a way that you can push everything your application needs to Git. And with that, that's everything I got.
I mean, that's amazing. We've had a whole discussion about sealed secret in the chat. You know, if you kind of want to explain how sealed secret works for folks for some context, maybe that would help. But I can give some layman's terms if you want.
Okay. I can try. So let's see. As I said, it's a controller running on your cluster. So let me change to the kubesystem namespace. And here we have the controller running All right, we have the select secret controller, and we have the private and public key. So here, if we look here, let's get this secret. Right, you can see that we have a certificate here. Okay, this is a public certificate. And now we have the key here. What happens is that when you run kubectl command, as I said, it will use your application credentials. Sorry, your application credentials not. Your Kubernetes credentials will connect to the kubesystem namespace, will read that secret, using the public key in that namespace, will encrypt the standard secret that you created. And that will encrypt the data inside the secret. And the tool, the kubectl, will add that encrypted data, which is this basically. So it reads the secret. The tool knows how to read a secret. Mm-hmm. So, for example, let me find the really quick. Okay. So the application knows that it should read the data inside the secret, and here it will find the different key values. And with the public key, it will read this value here and this value here, and will use the public key to encrypt the data. When it has encrypted that data, it will create the CR, which is the sealed secret. So we have here a CRD, which is called sealed secret. This is an instance of a sealed secret. And what it does is it creates, instead of data, it calls it encrypted data. And here we can find the different keys that were present in our standard secret. We had a password and username, and it puts the encrypted data here. And that's the file that you create. Then, when that hits the Kubernetes API that gets created, and you have here a code, which is the secret select controller, which basically is watching for select secrets in all your cluster. So if we look for the CRD, we can see that we have this CRD called select secrets, and actually we should be able to see something in the logs. So it will detect that a new select secret has been created. As you can see here, the namespace where the select secret was created was reverse worst states. The name of the select secret was my test secret, and it went ahead and decrypted the secret using the private key that the controller has access to that. And that's how it works. So then
that's awesome. Thank you.
It receives the select secret and plays the secret. That's it.
Beautiful. Awesome. So I feel like that should answer everybody's questions in chat about sealed secret. So that covers that. I'm scrolling back through. Ryan, did you notice anything?
No, I didn't see anything. I don't think we missed any other questions. I think Christian was helping out as well. So
yeah, no, Christian has been a huge help during the stream. Thank you so much, Christian, for jumping in and helping out. Waleed, thank you so much for all your questions as usual. I promise I'm trying to get you something. It's a work in progress. It's very unusual. I'll just leave it at that. But yeah, so thank you both, Ryan and Mario, for doing this wonderful presentation demo today. Joining us on the stream is so fun and so exciting for me, and watching this happen kind of live is great. So thank you so much for doing it. Thank you to everyone that has followed us during the stream. I think I have seen the follower stream exploding OpenShift O more this stream than any other stream. So if you have followed us recently, thank you very much. I appreciate that greatly. That is a metric that we track and is good for me. Thank you. So Anything else, guys?
I want to mention something. So we have, let me go back to Firefox. So in case anyone wants to start looking at ArgoCD, you can go to learn.openshift.com, and we have some categorical scenarios there that you can use for familiarize yourself with the ArgoCD tooling. So if you go to CI/CD application delivery, you have basically an introduction, which will be using Argo CD to deploy to a single cluster. And then you have the multi-cluster scenario where you have 2 clusters and you deploy different applications to different clusters. You just customize and so on and so forth. And then, of course, you have the introduction to OpenShift pipelines. So feel free to go through them, and that should help you to get up to speed.
Yeah, like the learn.openshift.com piece is very, very helpful for people getting started. If you want to kick the tires without having to fire up your own infrastructure, this is actually going to create a real OpenShift environment for you that you can tinker with and break and feel okay about. So yeah. Awesome. So without further ado, we will wrap this stream up. That is all for streaming for today from this channel. However, tomorrow we've got some cool streams coming for you. So we are going to, Rob Zumsky is going to come on. He's going to show us how to run a kubelet without a control plane. That's at 9:30 a.m. Eastern time tomorrow. So that's 13:30 UTC. And then at noon, we'll have a pragmatist guide to Wardley mapping. It's OpenShift Commons briefing from Ben Morser from Hired Thought. So yeah, that should be super fun tomorrow. So yeah, tune back in tomorrow, same bat channel, folks. Thank you very much.